All right, our next speaker is Dr. Carl Rosen. He is professor in the Department of Soil, Water, and Climate. He is the former head of the department, and now he's a much happier man as he spends more time with his students and his research. So welcome, Carl.
Well, thanks, Bruce, and thanks for the invitation to be at the conference today. I'm going to be talking about some of the work over the past 3 years we've been doing on chloride cycling and potassium response from potash fertilizer and manure in corn and soybean systems. So give you an idea of the topics that we'll be addressing. We'll give you a little background for why we're doing this study, a little bit of the rationale, and then go over a 3-year study that we've been doing looking at corn in rotation with soybean and then back to corn again. And then hopefully next year we'll go back to, or this coming year, we'll go back to soybean. We'll get into some of the results, the yield responses, uptake of these nutrients. Let's see, I need to move this down here that way. And a little bit on the uptake, and then some chloride leaching estimates, and then conclusions and next steps. So that's what we'll be looking at. So potassium, as you know, is an element required in relatively high amounts for crop production. Typical uptake can be as high as 200 to 250 pounds of potash for corn, a little bit less for soybeans. If you look at some of the book values for removal in corn grain, about almost 0.2 of a pound of potash per bushel. In corn grain, and about 1.1 pound per bushel in soybeans grain. The recommendations for potassium, as Dan mentioned, there's some issues with it, but we do base it on the soil test. Also placement and yield goal, that's what we look at. And there's a wide range of soils that are used for corn and soybeans, as you all know, mostly under dryland conditions on fine textured loess or glacial tilled soils. So these are the recommendations for potash for corn. You can see that we base it again on the yield goal. We have the different categories from low soil test up to very high levels, and then medium, high, and so forth. And then we also give some credit if you band it versus broadcasting of the fertilizer. You can have a little more efficiency with banding than broadcast. So those are the recommendations that we use for potash recommendations. And then for soybeans, it's basically based on broadcast applications. Most of the research with banded has not shown any advantage. So all of our recommendations are based on broadcast applications, also with yield goal and soil test level. So we know quite a bit about potassium, but we wanted to, when we do studies with potassium, we often neglect what's going on with the potassium. And one of the more popular fertilizers that's used is 0060. Muriate of potash contains 47% chloride in it. And the state of Minnesota is scrutinizing chloride-based fertilizers more recently, mainly due to the chloride leaching and runoff. Chloride is a problem for aquatic life. There's a limit of about 230 parts per million set by MPCA in water, and some lakes and rivers are impacted by chloride. And so there's an effort to try to figure out how chloride cycles in our ecosystems. And as I mentioned, a lot of the chloride is really due to road salt. We use a lot of it in the winter so that we have fewer accidents on the roads. But about almost a quarter, 23% of the chloride that's imported into the state is in the form of potassium chloride fertilizer. So there is a significant amount that's due to that fertilizer. So we wanted to get a better idea of what's happening in our cropping systems. So that's kind of the main rationale for the study. But on the other hand, chloride is actually an essential nutrient. It's essential for the plant, and if chloride's not there, plant can't complete its life cycle. So, and it's often neglected, as I mentioned, in potassium studies. It's taken up by the root as the chloride, and it's a chloride anion. It's very similar to nitrate in how it moves in the soil. It's very soluble. It's considered but unlike nitrogen or nitrate, it's a micronutrient. The amount that's required by the plant is very small. So you don't need a lot of chloride to satisfy the needs of the plant. However, if chloride is in the soil, it's taken up in macronutrient quantity. So it could almost be considered a macronutrient in the way that it's taken up, but in terms of need by the plant, it's considered a micronutrient. And if you look at the amounts in the plants, can range anywhere from about a 0.05% to up to 2%. 2% is a lot of chloride in the plant. Some plants can take up quite a bit. And because it's there in the soil, in many cases, the plants will continue to take it up. And if you have high chloride, it can be detrimental to plants due to the high salt content. And some plants are more susceptible than others. Soybean is one crop species that is sensitive to chloride. And Dan's shown some data in previous years where application potassium chloride at high rates can actually detrimentally affect yield. So do need to be cognizant and aware of chloride in the system. Another interesting aspect is that we talk about chloride. That's the anion, it's the inorganic form, but chloride can be incorporated into organic compounds, very similar to nitrogen and nitrate that's incorporated things like amino acids and proteins. But unlike nitrate, where we know where the nitrogen's going, what's being used for, there's a lot of organic compounds in the plant where we don't really know what the role of is in plant nutrition. I've reported in previous years that chloride has been linked to lower disease resistance, lower disease incidence, can resist disease with chloride there if you're deficient in your soil in chloride. In soils, particularly as you go into western Minnesota, where there's high potassium, less potash being applied, you can run into some chloride, low chloride soils. And so there has been some improvement in disease resistance when you apply potash fertilizer in those situations. There's also an interest in, well, how much is when we talk about the cycling of chloride in terms of where it's going, how much is actually being taken up, how much is being removed? And so those are some of the questions we wanted to answer in this study. When we look at the cycle of chloride, it's fairly simple. It's not as complex as nitrogen or phosphorus or even potassium, because what we're seeing here is basically three main pools. You have the inorganic chloride in the soil solution. It's a little bit in primary minerals. And then there's probably a little bit going back and forth with the organic compounds. So those are your main pools of chloride in the soil. If you look at what your inputs are, you have mineral fertilizers, obviously, with potassium chloride, potash. You have some residues going back into the soil. Plants take it up, goes back in. You have some atmospheric deposition, and also manure and compost biosolids. So will also have chloride, and that goes back in. So that's the inputs. You have your pools, and then you have some transformations, which are pretty minor compared to some of the other nutrients that we've talked about. And then you have the losses, which is what we're also interested in. A lot of it can be leached. It's very similar to nitrates and anions, so it doesn't really attach to the soil particles, so it's highly leachable in the soil. You can also get some runoff and erosion. We have some removal by crop harvest. And like nitrogen, you can get some volatilization. You get some microbial transformations to atmospheric type forms, usually methyl chloride, chlorine, and but it's usually small amounts. So most of the losses are going to be by leaching or runoff. That's the cycle. Whoop. There we go. So the overall objectives of the study that we're conducting evaluate the effects of potassium rate and source, and we're including manure in this because that's a source of chloride on yield of corn and soybean. We want to look at various potassium management strategies on potassium uptake and chloride uptake, chlorine uptake, and then evaluate the effects of potassium management on chloride leaching. So this is the study. We started it in 2023. The first year was corn. 2024, we rotated to soybean, and then we went back to corn in 2025. So we have a lot of data for 23 and 24. We only have yield data for 2025. And we're still working on some of that data. So if you look at where we did it, we did this at the Rosemont Research and Outreach Center, just south of campus. It's a silt loam soil, Waukegan silt loam. It's basically about a 1.5 to 2 feet of silt loam, but then it's over gravel. So there is it can be leachable in that situation. We did not irrigate. It was all dry land. We had 11 treatments that I'll go over in just a little bit, replicated 4 times. And we installed, one of the reasons we did this, we had permanent lysimeters installed in 2022 at the 6-foot depth. And these are we use suction tubes, as you can see here. We trenched it out, and we have right here, these are what we call lysimeter alleys. So we have selected plots where we put these lysimeters in, and then we could collect samples in these alleys without getting into the plots. So these were installed in 2022, and we maintain these through the course of the study. Okay, so a little bit about the chemical properties in the soil before planting. It's a kind of a moderately acid pH, 5.6, 3.5% organic matter. The soil test levels are kind of in the medium range, range from 69 up to 130. So there's quite a bit of kind of a variable site, but an average of about 93 parts per million. And then we did measure the chloride in the top 2 feet, which was about 45 pounds per acre chloride, which is kind of in an average, kind of a level where we wouldn't expect to see a chloride response in that at that level. So these are the treatments that we had. These are the 11 treatments. We had a control, obviously, no potassium applied or chloride. We went to 50 pounds potash per acre, either as the chloride source or the sulfate source, 100 pounds, same, 150 pounds. And this is all pre-plant broadcast. And then we also looked at manure, 150 pounds per acre. This was just coincidence because we based our manure application on the nitrogen content, not the potash content, but it was just coincidence that it was exactly 150 pounds. You can see how much chloride when we add this with the fertilizer, with the potash fertilizer, going from 38 to 113 pounds per acre. And I have a question with the manure, and I'll get into this in a little bit. Based on the manure analysis, we were only applying 4 pounds of chloride in this 6,800 gallons per acre. And this is liquid dairy manure. And this was applied again in the spring before planting. We also have another treatment, 10 and 11. where we were applying, basically it was the same rate as 2 and 3 this first year. But we then in 2024, we continued that application for the soybean crop. So it started to change in 2024, but in 2023, 10 and 11 were basically the same as treatments 2 and 3. We didn't want this to be a sulfur study, so we made sure that we applied enough sulfur in the plots. There is a little bit of question. We didn't put any gypsum on in the manure treatments, but this did supply 35 pounds of sulfur, which theoretically should have been enough. Okay, so those are treatments. So that was in 2020, 2023 and 24. I should go back up here. In 2024, we did not apply any fertilizer to the soybean crop except in treatments 10 and 11. 2025, we went back to corn and applied treatments again, similar to what we did in 2023. The manure obviously was a little different. We weren't as lucky, and we did apply a lot more potassium with manure based on that 150 pounds of nitrogen. We applied 15,200 gallons per acre, almost over twice as much. It was a wet spring, so I think our liquid dairy manure was somewhat diluted that year. And so we had to apply a lot more to supply enough nitrogen to satisfy the crop. We did have enough sulfur there in the manure. In all cases, we had about 50 pounds of sulfur in all of our treatments. Okay, so that's kind of the background. Little bit of about the weather, and going to be significant when we talk about bleaching. 2023 was a very dry year. If you remember, only about 6.9 inches during the main part of that early growing season, and only 16 inches total throughout the growing season. So a lot of there was fairly timely rain, so the yields weren't that impacted, but it was a drier year compared to 2024 and 2025. And this is going to have a lot of implications for how chloride moved in the system. Okay, so what were our responses? So the corn response in 2023, we did not see any significant effect of potassium or chloride on yield in any case, in any of the treatments. It's pretty flat. We would have predicted, if you look, so we were kind of on average in the medium soil test range, and Dan showed, maybe 25% of the time you'd expect a yield response. Well, we did not see a yield response in 2023. Numerically, our highest yield was at the 150 pound rate, but it was not significant. And surprisingly, the manure treatment was numerically the lowest. And what we have here, so this is the potash rate on this axis down here, and this is manure and calcium chloride. I didn't mention the calcium chloride treatment is a treatment with chloride without any potassium. So we wanted to get that chloride response without potassium. So if you look at the manure treatment, it was numerically our lowest, not significantly lower, but it was numerically lowest, which was kind of surprising to us. But those were the data. And then in 2024, however, this is where it got a little interesting. Again, we didn't see a response due to potassium rate. These are the chloride rates up on top. But we did see a significant increase due to manure. And again, the manure was applied in 2023, not in 24. So this is carryover effects of manure on the soybean crop. So the other thing that we found is that when we applied potash during the current season to the soybean crop, we did not see any negative effects on yield. So smaller amounts, 50 pounds potash per acre, we did not see any negative effects on yield. But the one thing we did see was a positive effect due to manure. We wasn't due to the potassium. We didn't really see a potassium response. We thought, okay, what could be going on with that manure? Maybe it was phosphorus. Well, our soil test phosphorus at this site is between 25 and 30 parts per million. So we don't think that it was a phosphorus effect either. Possibly it's due to some nitrogen effects, some residual nitrogen. We didn't apply any nitrogen to the soybean crop, but normally there's been enough soybeans at this site that there should be enough rhizobium, atmospheric fixation with rhizobium. So we're not really sure what's going on with the manure, why we got this significant increase. And it was significant at the 1% level. So it's a very significant increase, but we're not exactly sure why that went on. Then in 2025, this past year, again, we didn't see any effect of potassium on yield. If you look at the manure response, unlike 2023, where numerically the lowest, now we got numerically the highest with manure. So manure did well in 2025, not so much in 2023. We don't really know exactly why. I think we're starting to see some potassium. Again, it's not statistically significant, but when we just applied calcium chloride, that was numerically our lowest yield. And I think we are going to start seeing, if we continue this study long enough, we might be able to start getting some potassium responses at this site, but we didn't see it even in 2025. Okay, so those are the corn responses in 2025. Okay, so what happened? Where's all the potassium? Where's the chloride going? I should have done this. This is potassium uptake elemental. I should have converted this to K2O, and I just realized I didn't do that. But it's almost the same. If you multiply these values by 1.2, then you get the potash value here. You can see that our amounts that were taken up, we had roughly about a 200 bushel yield in 2023. Overall, I would say our uptake is a little lower than the book values for 2023, and this could have been due to the dry year that we had. It was very dry that year. We did see that potassium uptake tended to increase with increasing potassium rate, going from here up to here. About a third to a half of the potassium taken up is in the grain. The rest is in the stover. So that means that potassium, about half of what is applied, or half of what's taken up actually, is going to be recycled back into the soil, assuming that all the stover is left on as residue. So a lot of the potassium, the plant needs a lot, the crop needs a lot, but a lot of it does get recycled back because it's not in the grain, unlike other crops. Looking at the chloride uptake, as opposed to potassium, where you're up in the 80 to 100 pound range, chloride is more in the 30 to 40 pound range. And similar to potassium, most of it is in the stover again. So a lot of the chloride that's taken up by that corn crop is going back into the soil. So it's just getting recycled into the system again. And one of the reasons I had a question mark on the manure, where it said only 4 pounds was applied, both in 2023 and 25, is the amount of chloride that was actually taken up by the manure is more similar to about 50 to 100 pounds of, or I should say 38 to 75 pounds of chloride, not 4. So I think the uptake of chloride when you have manure applications, in this particular case, is higher than expected. And I think more research is needed on chloride analysis of manure. And it may be that, as I mentioned, there are organic forms of chloride in not only in manure, but in plant tissue as well. So maybe chloride analysis, when they do chloride analysis in manure, it's chloride, you're not getting total. So there could be something going on with that. So I think more research is needed to try to figure out what's going on in manure, and maybe Melissa can address that in her talk next. Okay, a little bit on potassium uptake on soybean now. You can see that when you apply potassium, this is where we applied it the current year. You're going to increase the uptake, and the uptake increased with 0060 MOP more than it did with sulfate of potash. So we got better uptake with potassium chloride. This is potassium here. Manure, that was the second highest. Now remember, this is residual amount of potassium from manure and for chloride, but we're still getting some pretty good uptake. So previous manure applications did result in relatively high potassium uptake. Again, similar to corn, about a third of the potassium taken up is in the grain. The rest is in the stover. So a lot of that potassium does get recycled back into the system. Chloride uptake, very low levels, as opposed to potassium, where you're up into that 160, 200 pound rate. Again, this is elemental, not potash. Very low amounts of chloride taken up by soybean. And again, most of it is in the stover still, very little bit in the grain. Only about a quarter of the chloride's taken up in the grain. So overall, chloride uptake in soybeans very low. This variety that we use may be an excluder of chloride. It again, and also didn't have very much. But when you did apply it, even when you applied it during that season, you're still looking at relatively low amounts of chloride taken up. Okay. Getting into where's that chloride going in the system? This is in 2023. So the corn, this is through the season. And if you look at these, I know it's a little bit small, but basically there was no consistent effect of treatment on chloride concentrations at the 6-foot depth. This is right at the beginning of the season, and you can see the levels were relatively high. It's what was in the soil. And this is just the concentrations, okay? So we could still suck up water from what's down there at the 6-foot depth. Calcium chloride, we'd expect to be really high in chloride, but you can see calcium chloride, this blue line here, is relatively low. And potassium sulfate, where we wouldn't expect chloride to be very high, was actually fairly high. So we're looking at this first year as probably these are background levels. And remember, 2023 was very, very dry, okay? And when we based loads or leaching loads on the amount of water that would be percolating through the system, so input rainfall, the output would be evapotranspiration. There was more evapotranspiration than rainfall in 2023. So there was no leaching. You don't have the rainfall, similar to what Lindsay talked about this morning. If you don't have the rainfall, you're not going to get any leaching. And that's what happened in 2023. We did not get any leaching. So I'm thinking these are just background levels that we're seeing. Okay, so, and this just shows you what the rainfall patterns were in 2023. And you can see we didn't have, there was one time where we had more than an inch of rain. We didn't start getting a lot of rainfall till well after the corn, till the corn had matured. So not much rainfall, not much leaching. Okay, So leaching in 2024, though, where we didn't really even apply that much, that's where we started getting, so the residual amounts of chloride were in the soil. That's where we started getting some significant leaching, and you could see a very consistent treatment difference. So most of the leaching occurred where we had a lot of rainfall early in the spring. I'll show that in a minute. The effect of chloride input was significant, as you would expect. And in this case, rainfall did exceed, input exceeded evapotranspiration. So that's why we got these very consistent results. And you can see here, this is the amount of rainfall. We got some very significant rain, even though it was just about an inch here, it added up so that we were exceeding, particularly early on, exceeding ET here. And then we got some very significant rain after the crop was up even. So got a lot of rainfall early in the season, and that's why we got some chloride leaching. And this, when we do a kind of a balance and look at the amount of load going in there, it's very consistent with treatment, very low amounts of chloride leached in the control, and where we had potassium sulfate. When we added the highest amount of, this is the highest amount at 100 pounds of potassium chloride the previous season, started leaching out. Same with calcium chloride. And again, another reason why I think that manure analysis is a little off, we got some fairly significant leaching from manure, probably more than the 4 pounds that we said was in the manure. So I think there's something going on with that manure analysis. And when we split the application, this is the current season where we put 50 pounds on, we did also got some leaching. So very consistent results and made sense in that leaching of chloride. I just want to let you know, this was in a dryland situation. We've done a similar study in irrigated. I'm not going to get into a lot of detail on that, but you can see that there's a lot of leaching that can occur under irrigated systems. This is in 2023 and 24 up at the Becker Sandplain Research Farm. We also note that just with irrigation water, when you use that irrigation, you can apply up to 100 to 160 pounds of chloride without even applying any potash fertilizer. You're adding a lot of chloride to that system because the chloride concentration in our irrigation water up there is at 40 parts per million. And that's been increasing over the years. So there is some issue with that. Just to let you know that you can have some high leaching potential in certain soils, particularly on sands. So this is my summary and conclude. The lack of potassium response in corn in the study, it's a little surprising, but after listening to Dan, maybe not so surprising. The soil test was in the medium range. You know, again, there's only about a 25% probability of a positive response. So we were in that. There is that issue. If we maybe as we draw down that potassium, we'll see more of a response. Our most significant finding was that 10 bushel per acre increase in soybean yield with previous application of manure. We don't think it was due to phosphorus, possibly residual N, or maybe some other soil health factor that we're not aware of. I do think that the chloride analysis, it may not be the chloride analysis is questionable, but the amount of chlorine or chloride that's added to the system may not be reflected in the manure analysis because we're not doing, I don't think, we're not doing total, we're just doing the chloride. About a third to half of the potassium taken up by corn and soybeans in the grain, so you get a significant amount in the residue. It's going to be recycled. Even more so with chloride. Only about a quarter of the chloride is taken up and removed in the grain, so the rest is going back into the system. Chloride does leach with excessive precipitation, and the greatest potential for leaching is actually more with when you have an irrigated system on coarser textured soils. So next steps, are going to apply. We still need to do analysis for potassium chloride uptake for 2025. We're going to be calculating leaching loads for 2025. And then hopefully we do have some AFREX funding for 2026 to follow up with soybeans. So that's the last slide I have. Time for questions? Oh, good.
Do you have any questions in the room? Yes, go ahead.
Yeah. That could be. I mean,
Carl, could you repeat
Oh yeah,
the
yeah,
question?
yeah, sure, yeah. So the question was, in addition to chloride, there's other components of manure, micronutrients, that could be also affecting the response as well. We did the soil test. We weren't deficient in zinc. We're above a 1 part per million. So it's possible there's some micronutrient responses that we're getting from manure as well, that we're not accounting for. But again, our soil test levels of the micronutrients were in the adequate range. Sulfur, again, we don't think it was a sulfur response because we applied sulfur. Yeah, I'm not really sure what's going on there. Yeah. Is there a manure history in the field? Not recent. If there was, it would have been long time ago. And based on the phosphorus levels, there may have, I mean, we're not excessively high. We were in that, range of, 25, 30. Oh, here's some other questions. And then 10 bushel increase in soybean yield from manure. Was there any analysis of sulfur testing? So we did analyze the manure for sulfur. It's 35 pounds per acre in there. And then 2025, we also analyzed for sulfur as well, and there was 50 pounds per acre. We don't think that it was a sulfur issue, although that's questionable. We should have, in retrospect, we probably should have added more gypsum to the manure plots, but just based on what I know about sulfur, I don't think that it was a sulfur response, but not sure. Did you say this was dairy manure? Yes, this was liquid dairy manure. And would you have different results from swine manure? I would say probably we would. Yeah, I mean, you're going to be applying different amounts of nutrient. I don't know what the chloride concentrations in dairy versus swine manure is, though. So I suspect there would be some differences. Yeah. It's fall apply. What was that? Oh, was the dairy manure? No, everything was spring applied here. Everything was spring. Yep.
All right. Are there any other questions for Carl? All right. Let's
All right.
give him a hand.
Thank you.